Right? Just make a note, copy that down, please. I want to make sure you have that before we move in, right? Copy those things down, make sure you remember that. The whole screen if you need it, but all I want you to really get is gradient, parallel lines, perpendicular lines, and how to find the equation, right? Just copy down that alone. Although you have it in your summary, but copy it down again. Tomorrow, don't read that summary. Right? All these things is just to remind you that parallel lines equal gradients, perpendicular lines, the gradients, product is -1, and how to find the equation of a line, right? Because that's what they will ask you, to find the equation of the tangent or the equation of the normal. What's how is the normal and the tangent related? Yes, sir? Yeah, how they related? Very tangent, okay. That can do. Nice. All right. So those are the things that I needed to know, right? We did differentiation. We have all the rules and summaries here, and we did the first application, right, to find gradients. Okay, so let's just try a couple questions. Let's try a couple questions on that, and then we can do the second application. Right, we're doing 2012, number 5. So we're going to do that from now. 2012, number 5. We try to get the equation of a line before that I showed you, right? You'll see that? I try to focus on that one there, right? 210 lies on the curve. Okay? This one here. Kind of one. I find the equation of a line type. So what you need to find the equation of a line type. Right? How you get the equation of type? No, that's not how we do it. That's how I thought we do it. Let me do part one, right? Let me do part one to give it dy dx, yeah. Right? So looking at part one right here. So the first thing you're doing is you're finding dy dx. dy dx is 6x plus 5. You okay with that? That's dy dx. Then we need to get the gradient of tangent. So I put in mt. I'm going to put x is 2. So that'll be 6 by 2 plus 5 to 12 plus 5, which is 17. So our gradient is 17. That's okay? That's the gradient of tangent. Next, you want to get c. C is equal to y minus mx. The y value is 10. The gradient was 17 and the x value is 2. 10 minus 34 is minus 20. That's okay. Are we done? We done. The equation of tangent is y is equal to mx plus. That's all. That's the equation of tangent. Right? It's important you all learn to revise. Everybody who lost. right? You had to go over these things, right? Find the normal now. And it's getting greater than normal. Remember? It's getting greater than normal. Normal is what? The normal is what in tangent? Normal is 90 degrees, right? So the perpendicular. So what will be the gradient of the normal? Right. Minus 1 over, right, which is minus 1 over 17, right? Go ahead. Minus 1 and 17. Find the equation of the normal after. Right, find next part. And let's go again. Right, it's important to check what point they give you, right? The point is that. Okay, you do the same thing again, right? You need C. To find the equation of a line, you need the gradient and you need C. All right, let's see what you got now. I'm rubbing up this here, right? So you want to find C. Right, you want to find C, right? So Y is 10 again. Gradient is minus 1 on 17 and X is 2. So that's 10 plus 2 on 17. Right, that's 10 and 2, 17. You can leave it like that. So your final answer is Y is equal to minus 1 on 17X plus 10 and 2, 17. Okay. If you want to make it look nice, you can multiply by 7. You're okay with that? Amisa, come on. Okay. Perfect, legal. Once it's perfectly good. Online, any questions? Try 2016 number 5. That's the one on top there, right? Right, I'll call you up and I'll correct it. Online, you can message the answers. 2016 number 5. Just to pass here alone. Yeah, that's part. That's the one on top. This one here. Right? Oh boy, I don't know. What a feeling. 2. Right, there you go with 2. Was it 2? That was looking like 7, but I think 2. Let's go with 2. Right, 1/8 equation, find the normal. Go ahead, ask what? Right, I'll give you 5 minutes, not call you up one by one, and I'm see where you are. Online is kind of escaping. I don't know how I call it. Huh? Who's the caller? Tell me. Oh, okay. You can pick one. Android? Android, you pick on Android. Alright, I'll work it out. Take your time. Look at how to differentiate that. I don't want to get that wrong. right? So to differentiate, it should be using product rule. Yeah, it should be using product rule, right? What's product rule again? Yeah, u is 2x and v is the x plus 1. What we have created on earlier? Squared? Squared? Yeah, we have squared. Right? What's the differential of 2x again? Based on your first name, okay, I was like, no. What's the differential of 2x? Again, really easy one again. Sorry, the other one. Huh? 2. Kai, what's the differential of x plus 1 all squared? So say, bring down the power, differentiate inside the bracket, put back the bracket minus 1 for the power. Right? So you kind of close it. Right? So your final answer will be 2 by x plus 1, or you can just write 2x plus 1. So what's the differential? The differential is u by dv dx plus b by du dx. But guess what? You don't have to worry about factorization. Why? Mamita, what is just about? That was just obvious, right? We don't have to go and factorize anything earlier, right? We don't have to go and factorize anything. All we have to do is to plug in x is 1. Good thing. All right, yeah. Come this question about our x. Come on. Right? Just plug in x is 1. So you'll get 2 by 3 plus 2 squared by 2. 2 squared is 4 by 2 is 8. 8 plus 6 is 14. Anybody got that? Then you know if you get negative 16. 2 squared is 4 by 2 is 8. 8 plus 6. Anybody got 14 online? Yeah. I know negative there earlier. So I get 16 like 14. Yeah. Huh? We got the 16. We get negative. You sure? 2x by 2x plus or 4. Yes, yes. I make a mistake here. It's supposed to be 2x plus 2. Two x plus 2, sorry. So that's 8 plus 8, which is 16. Right? So what's the granted in normal? Negative reciprocal. Gradient of normal is minus 1 on 60. How much you all got to see? Finish that question earlier. Find the equation. All right, yeah. What you all got for C? C is y Where's y again earlier? Y minus mx m by m. Yeah, what you all got? 8 and 116. Sorry? Yeah. Yeah? Yeah, 8 and 116. Same thing, same thing. So y is equal to 1 on minus 1 on 16x plus 8 on 160, right? I like how you're doing this. Let's do one more. All right, let's go again. Right, one more before I switch it up. Push up, kind more. All right. Let's do next application, maximum, minimum. I don't have any more in that section, right? Next application, maximum and minimum. All right. So now we want to do the next application. The next application is to determine the points and maximum, right? Maximum and minimum. Maximum and minimum, right? Write a small note to determine a big function. To determine if a function has stationary values. To determine if a function has stationary values. Right? To determine if a function has stationary values. What are stationary values? This and this, right? If you were to draw a tangent here, how would it look? It will be horizontal and Jaden. Right? So to determine if a function, and what's the gradient of this? 0. So to determine if a function has stationary values, right? Stationary values occur when dy dx is equal to 0. Right? Stationary values occur when the differential is 0. That's okay? You'll see that there. You'll see that there. Right? But how do we determine if the max or min? How do we determine if the max or min? Real easy. Right? Oh, this is something I didn't give it a small note on. Crap, that's my fault. Sorry about that. I'm supposed to tell you what d2y dx squared means. Right? Real easy. All this is, it simply means differentiate twice. Sorry about that. Right? I was supposed to give it up. Right? What you say? If y is equal to 2x cubed minus 3x plus 4, what is dy dx? 6x squared minus 3. Coming on. So what is d2y dx squared? 12x. That's all. Right? So just go back and make a note of this place and draw these two diagrams. Sorry about that. Huh? No, I make a mistake. I'm supposed to give it a and you pull this. Copy that out, please.
Yeah, yes. No, upgrading class. Even Abyan normal. No, it's not. No, but. Oh, in minutes, so that's right too. Yeah. Yeah. I'm not in fact. Yeah. No. Yeah. It's not true. I will give the structure that everything.
Right, so how do we know data? So how do we know if it's max or min now? Right? So so this was something I'm supposed to give you at the beginning, right? First differential is this, second differential is do it again. Simple enough, right? Right. How do you know? So after we figure it out, right? After we figure out the stationary points could be maximum or your stationary points could be minimum. Anybody remember how to know before we do differentiation? Right. You look at E, right? But the problem is you don't really have E's alone here, right? You don't always have quadrants when you have cubics and then. So a method that will always work is this. You have to find d2y dx squared, find the second differential, and if it's less than 0, maximum. You have to find d2y dx squared, and if it's more than 0, when you plug in the value, if it's more than 0, it's a minimum. That's okay? That's what you're looking for. Second differential, less than 0, you have a max. Second differential, more than 0, you have a min. Okay? Nathan? On to 4 now. What's that? Over this? Right. So after you find your stationary points, right? After you find dy dx, for you to know if it's max or min, you have to differentiate again. And take the value from here. If it's less than 0, maximum. More than 0, min. I'm going to show you an example now. Yes? Yeah, general. No, it's like general. Something in it. Right, so I'm going to show an example here so you'll understand what to do. Real easy, real. It's probably the easiest thing. Well, not all the questions, right? Online, are you okay there? Elizabeth, Renisha, are you okay? All right. Ready? Let's go through this one. Again, you're going to struggle if you climb out to differentiate, right? Right, but that's what we've been doing for the past week and more, right? So I hope you remember to differentiate. Good. So they asked us to find the nature of the stationary points. So nature means is it max or is it min? Stationary points means these values here. All right. So step number 1, Lisa, is to find stationary. So stationary points occur when dy dx is 0. That's okay. So number 1, let's find dy dx. dy dx is what? Differentiate this amount. 15 x squared squared minus 4x squared. 2 by 2 is 4. Minus 4 plus 0. Nice. So that's dy dx. Next, take 15x squared minus 4x minus 4 and make it equal to 0. Somewhere again on a calculator. X is what? Huh? X is 2 over 3 or minus 2 plus. So those are your two values for x. Are you okay with that? Now, which is max and which is min? Oh, by the way, we still have to find the y, right? Just do my paper now. Put it in the calculator some more again. Take this and put it in here some more again for y. Take this, put it in here some more again for y. Mesa, you don't like it? One fractions on them. Right? Take the x value, find for y. Take the x value, find for y. Because we need the points. In here, it's in here. Not this one. If you put it in here, you will get 0. Right? You will get back 0.
Yeah.
But instead you want to get y.
2 over 3, I get 15 over 7. 27.
Anybody else get that? Check it again. Huh? Anybody online? Put 2/3 in here. 1 over 27. Can it get in there? Hopefully you'll get the same answer soon. So online get anybody online get it?
I get 15 or 27.
How much you getting, sir?
Look,
Renisha got 25 on 27 too, so you go with that. Put it in the card, Renisha. I mean, I'm reminding you out in here to put it in, work it out. Waiting on Rema doing this one first. Put minus 2 pips in here.
That's enough.
How much you got here? How much? 99 over 25. Right, Elizabeth, get that too. Nice. So these are the points. So these are the points, the x and y value. Now we want to see if they are max or min. So let's start here. Let's start x is 2/3. So let's find d2y dx squared. Help me out here, Nathan. Mohammed. What's the second differential of this? Well, what's the second differential? Differentiate this again from where you get. Huh? So that'll be 30x minus 4. Right? And then what? Watch here. This is the important part. After you differentiate, take the x value and put it in there. So that's 30 over 2/3 minus 4. So that's 10, 20 minus 4 is 60. Is that more than 0 or less than 0? More than. So therefore, this is minimum. That's okay. And you can't have 2 minimums already, right? So more than it is maximum, right? So you have d2y dx squared 30 by minus 2 pips minus 4. That's 6 minus 12 minus 4 is minus 16. Therefore, maximum. Okay with that? Okay. So we have the stationary point, and we know this point is minimum. So ideally, you should write this, right? Hamlet, you okay with us? This point is minimum. This point max. Hamlet, okay? Lisa, you okay with us? Come on, forward, right? I'm bringing you forward to the next one. Okay, So all we doing, differentiate equal to 0, stationary. Double differentiate, plug in the x, nature. That's okay? Try again, stationary. Prima. Try again, stationary. Try again, stationary. Make it equal to 0. Try again, maximum. And then plug in the x1. Copy now. Are you ready? Let's go. Take your time on for this one, please. (2013) number 5. See it there? Alphatic 5, right?
Where?
2013 number 5. 1, 2. Right, we're going to pass as you do it. Take your time, follow this step, right? Want to do that now, right? Everybody getting through online? We need to do that. No. Part one is just that thing over here. Divide the X. Huh? Part two is to get the action. Alright, let's go. Let's see what you got. So part one, they have the coordinates of the stationary points. So we need dy dx first. Dy dx is 3x squared minus 6x. And then we tell them stationary points occur when dy dx is 0. So 3x squared minus 6x is 0. You'll get x is 0 and x is 2. Correct?
Yeah.
Okay, that?
Yes.
X is 0, x is 2. Right? That's the first part. But you have to find the y value. When x is 0, I got y to be 2. And when x is 2, I got y to be minus 2.
Okay.
So we know the stationary points. Okay? They want the coordinates of the y value, so give them y is 2 and give them y is minus 2. That's what they asked for, right? The y values. Next, find the second derivative of y. So d2y dx squared. What is the second derivative? Isa, what's the second derivative?
It will be 6x minus 6.
Nice. And then determining nature. What to do? Plug in. Yeah. What to do? Plug in what? Yeah.
You plug in the x values.
Right? Plug in x is 0. And you will get less than 0. So therefore, maximum. Honestly, you don't need the exact value. You just want to tell them if it's less than or more than. Okay. When x is 2, you'll get 12 minus 6, which is more than 0. Therefore, is up. That's it. That get easier than that. You got through that? Right? Copy it down. Let's go again. Time is out to finish. Very good fun. Okay. Glad to be on the board. Right, try, right. Oh, yeah. Copy that one down fast, guy. Do 2014 number 5 when you finish. Look it right here. Online, any questions? You'll get through. Right, nice, nice. Phoenicia, good job. P8 to be nice. We get an answer. Oh, yeah, next one. Let's go again. I'll chance to me, right? It's 2014 number 5. Oh, this one, yeah, assuming it. Quick as the word. Quick as the word. Oh, yeah. I didn't know if you asked to do it. How do you do that? Why see you get it? Don't message nobody. Can I give a question to do? Can't believe it. I'm not more than that. She doing class. I message about. Come on, they work on this fast. Time almost up. Okay. So, alright, so since Kai on your phone, Kai, you go do this one. QIDX is what? Come on, what? QIDX here.
Squared.
6x squared minus 24. Anybody can solve this fast enough? Well, those who did it. What are the x values? You can make this 4 minus 1. Of course, you have to go and find the y values, right? What is d2y dx squared, Kai?
6x minus 12x minus
Right. And how to determine the nature? What to do?
this.
Go back in the x values and see what you get, right? So when x is 4, I got more than 0. So therefore minimum. And when x is minus 1, less than 0, therefore maximum. Are you okay with that? Remember to find the y value. Next day, we'll do a few more on these and then some hard ones. Right? It has some hard ones where it's a real life scenario and you have to find the max and min. Right? Some of you all may do this as a project. I'll give you one that can be done at the